So we did talk about linear regression, what it is, and we've been talking about pre-processing for a couple of days. But now I'll talk about post-processing, right? So what we did was after training, okay. So what happened? You need to train the model, right? And
Yeah.
after training is what you actually, you get um, uh, the way to predict, right? And that's why training is important. Okay, training is where we kind of have all the applications. Okay, okay. So okay. So see, when you do training, okay, I'm just trying
Mm-hmm.
to see to think how to explain. So in simple, okay, so it's easy to understand yesterday. So when we created that best fit line, that is what happens at during training stage. Okay,
Yeah.
during training stage you create that best fit line, and once you
Mm-hmm.
have the best fit line, the prediction is easy, isn't it?
Yeah.
Okay? Best fit line will give you the equation mx plus c. Once you have it, then you can predict for any value, right?
Mm-hmm.
So that's the whole objective. Whole objective of any model is to train, and training takes time. Training is training is what actually helps you to make sure that you understand the process well and reuse it, okay, for prediction, right? Now, if I
Yeah.
ask you a question, okay, if I ask you a question, you don't answer immediately, isn't? I mean, so you can answer immediately, but
Mm-hmm.
your answer that you do is based on all your past experience,
Mm-hmm.
right? So you cannot say that generally somebody say that that, oh, I read history, but that history is not useful to me,
Mm-hmm.
right? But it's not the case. See, what you are today is based on your okay is based on all your past experience, isn't it? Based
Yeah.
on what you have done, and today what you are is based on those training, and that's why training is important, right?
Yes.
Okay, and training is where it takes effort, and once you have it ready, it becomes easy for prediction. Prediction is what? Just follow the line and you get that.
Mhm.
Okay, so that's what we do when we talk about learning. Okay, so learning we did. Now let's see what we do once learning is done. So I'm going to, let's say, predict the data. Okay, so let's predict the data. So predict, we use a predict function of CA tools itself. Okay, now what we have was we created this regressor, right? Now to predict the value, okay, and we did create training set and test set. Okay, so this is
Mhm.
the training data for training. Now what I'm going to do, I'm going to create data frame, okay, called, let's say, y predict value, something like that. So this will have all your y predicted. Now you say predict. Predict what? Regressor. Okay. So regressor has a training set that has that line, right? Your regression line, and it needs a new data parameter, which is your the data to on which you want to make prediction. So we
Mhm.
set it into training and test because we wanted to do this on test data. So once you run this, okay, you get pred value, and that pred value is your prediction. Now, if you want to compare how your prediction has done with respect to um, actual data, so we can create a data frame called comparison or something equal to, you have C bind. C bind is to combine two individual frame together, right? Two columns together. So I'm going to say here test set. Okay, this is the original data, and y
Mhm.
pred that comes from your predict, this one. Okay. Now you print the value here. Print comparison. Okay.
Okay, new way take of this set. Okay.
Sorry.
Yeah, yeah. No, no. I was just reading out the formula.
Okay. Okay. Uh, okay. You see this. Okay. This was your test set. Okay. So
Yes.
your marks is 32. And what are you predicting? 29.
Mm-hmm.
See, this is what machine is predicted based on the training data. Test data, we have never exposed it before. So test data, okay, the model doesn't know, model doesn't understand.
Yeah.
Model doesn't understand the test data, right? What model understands is only your the training data, right? Based on that, it has learned. So it is like asking different questions in the exam. You train the model with different question, and now you are asking different questions in the exam. So, okay, so based on whatever it has learned, it is predicting. Okay, you see? So actually it was 32 is predicted 29, 37, 30, 30, 32, 35, 35. Here almost correctly it has predicted. Okay, so your prediction is ready. Great. So you have predicted. Now, after prediction, how do you, okay, how do you know how much actual data has predicted? Okay,
Mm-hmm. The
or
percent.
or how well the data has predicted. See, if you talk about just one, we know that okay, it has predicted less by almost like 10%, right? You can say that it is like 92% accuracy, right? Something like that. But we have so many data set. How do you read this? How do you analyze this? Okay.
Mm-hmm.
So again, it goes back to our variance and standard deviation equations. Okay, and I'm going to show you in Excel how things are getting calculated. Okay. Okay. So let me share my screen. You see the Excel file? You see Excel file?
Mm-hmm. I see the Excel file.
Okay. So now in Excel file, let's say, okay, this is your actual value. Okay. I want to see how well my model has predicted. Okay, what is the performance? I want to evaluate the performance of my model.
Mm-hmm.
Okay, so I write actual here, and then here I write predicted. Okay, so let's say 32, 29. Let's say 32 is actual, 29 is predicted. Then 37, 30. 37, 30. 30, 32. 30, 35, 35, 32, 37. 35, 35, 32, 37. Okay. 45, 42, 44, 44. 45, 42, 44, 44. Let's take this data and see the calculations. Okay. Now, okay, so this is your actual, this is the predicted. So what you do is you want to know how well this has predicted, right? So we'll find the difference. Correct? The difference we say 32 minus 29, let's say. Okay. And now let's say, I have calculated the difference. Okay. So this is the average, this is the difference of each value, right? How do I, okay, okay, how do I find the uh, uh, average difference? Okay, so to find average distance, difference. Now see, when you're running a model, if one model has only 5 data, other model has 50 data, obviously the 50 data will have more error, right? Okay, if you
Yeah.
add them all together. But that's not the real way of, that's not the actual way of comparison, right? You have to divide by n so that you get average error. So if you have to calculate, if the difference is your error, right? So we'll say average error, let's say.
Hey, sorry, sir. Can you like repeat it again? Sorry.
Right. So I'm saying that this is your error for each row, right? Now I want to calculate average error. So your average error will be, okay, sum of all these error, okay,
Yeah.
divided by n, which is 3 plus 7. So your average error is only 0.857. It looks so accurate, isn't it? It's
Yeah.
not even 1. So your prediction is so accurate. But that's not true. You have values 3, -5. Now, whether you say -5 or +5, error is error, correct?
Yeah.
You cannot say that -5 and +5 will cancel out. This is what is
Mm-hmm.
happening here. Okay, +5 and -5 is canceling out, right?
Mm-hmm.
That's where we see the error is so less. But that should not be the case, correct? That shouldn't be the
Mm-hmm.
case. So what we do is, okay, instead of doing average difference, there are two ways to see. Our intention is to make this negative also positive, right? So there are two ways to calculate. One way is that you square the numbers. That's why your negative will become positive, right? Our second way is that don't square, but you do the absolute difference. Okay,
Okay.
absolute. Okay, absolute means, okay, difference will be positive even if it is negative,
Yeah.
right? So okay, so average is also called as mean, right? So sometimes this is called as mean error. Okay, mean error means you just add them together. Now I'm finding the absolute difference or absolute error. So absolute error. Okay, absolute error will be 3, 7, 2, 0, 5, 3, 0. Right? So now calculate this value. This is called as mean absolute error. Correct? Absolute error is this, total absolute error is this. But since
Mm-hmm.
we have 7, right? We are dividing it by 7 and you are getting mean absolute error. So this is one metric. Mean absolute error is one of the metric which we need to
Calculate.
write, right? Okay. Now, so this is first method. Second method is that, okay, say, okay, let me square it. Square error. Okay. So you square the error. So you say 3 into 3. Okay. So you get this. Now, so what is the error? You say 13.7, right? So what is 13.7? This is your mean squared error,
Error.
right? This is squared error.
That is absolutely right.
This is, yeah. So, so this is your mean. So mean squared error is one more metric that we look at. Okay. But the problem here is when you look at mean squared error, okay, it may not, it, it may not look um, good because see we started with x, right, and we did x square. So
Mm-hmm.
you can always say that we are not comparing apples to apple, right? We started with unit and you did square, so it is square unit, right? So
Yeah.
that's not a good comparison. You have to compare same unit, right? So you'll say okay, fine, let me do the square root of this.
Mm-hmm.
Okay, so you say okay, square root. So SQRT is the formula in Excel. You do the square root of this. So what do you get? You get as mean, no. So this is root, right? So root mean squared error. So 3.7 is your
More up. Yeah.
root mean squared error. Okay,
Mhm.
and this is one of the important metric that we use in regression. Root
Okay, so
mean squared
we
error.
so this is what we talked about yesterday, right? Roots are
Exactly.
RMSE. Oh, now I understand.
RMSE, exactly. I talked
Yeah,
about.
I was going to ask you, like, I didn't understand what RMSE
Yeah.
is.
So I told you that we'll do it. Okay.
Okay,
Both
yeah,
R
yeah.
square also we have see R square formula also I'm not sure we will do it. Okay.
Okay.
So I just said that R square is comparing your average value. Comparing your regression with average. Okay.
Yeah.
We'll see. We'll see. I'll show you the formula later. Okay. So RMSE is actually, so you have MAE, mean absolute error, mean squared error. Okay, these are also a metric that we look at. Okay, but technically we should look at RMSE. That's why you see you will have mostly RMSE on your generally the metric that we look at. If it is about one metric, that's the one metric.
Mhm.
Okay, but let's say if you're talking about, if they ask you what are other metric, or let's say you are doing some kind of certification exam and you have multiple choice. Okay, so you have to be careful.
Hello.
Okay, sounds good.
Yeah.
Okay, and we'll, yeah, so R square is still pending, we'll do that, we'll do R square. Okay, now let's see how to
I have a question. So, like Tableau, there are like inbuilt statistic functions already. So you just have to like pull the um uh, 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 like the chart for like regression, and it pre-calculates the R square and like everything. So for Tableau, we don't really need to like use R to build a linear regression, is it?
see. Okay, okay, see, to build linear regression, right? The
Mhm.
concept is same. You're finding the best fit line, right? Now, how you find the best fit line is the question. So regression you can build even in Excel also. You can
Yeah.
build in Python also, R also, right? So if you're talking about Power BI as such, okay,
It doesn't have that function inbuilt.
exactly. Okay.
Yeah.
The Power BI on itself is not the one, because Power BI is used for data visualization. Okay. That's why Power BI is designed for. Okay. It's it's a BI tool, business intelligence tool. So
Yeah.
business intelligence or business analytics is, or data warehousing is all about what happened. Okay.
Mhm.
By definition, BI will not have the prediction part to it.
Yeah.
If you talk about SAS, SPSS, R, Python, these are the tools which has been designed for prediction.
Mhm.
Okay, so by definition, it is not there. Now, if if Power BI is built with, now, because um, um, okay, because Power BI is popular. Okay, Microsoft can say, okay, let me add regression to this, right?
Mhm.
So Power BI can create your regression, okay, and I think it can only create your simple or multiple regression, not like SVM or those things.
So my question was in Tableau there is already something called analytics. I mean, if you click on it, there are options mm, for options to select like regression. So do you want like linear regression and all that? So if you click on that option, it created, I mean, I gave X and Y, and it created, it created uh, a, a regression line. And when I just
Yeah.
hover over it, it was showing that uh, mx plus c formula, and then
Exactly, exactly.
yeah, then the
So
r
see,
square
that
value.
so
So for
linear
that, I
regression,
don't need, yeah,
linear
sorry,
regression is easy and you can create it using Power BI or the Tableau also.
Tableau. Okay.
Okay, but there, did you try to drop down and see what all other options are there? Did you see decision tree or
Yeah,
SVM?
yeah, I saw some. Yeah, there are like few options, but I don't think like all the options are like available. But I just saw like regression. I mean, in regression there was poly something regression, and
Polynomial. Yeah, yeah.
yeah, polynomial regression. So there were like two or three options in like regression. So just I mean, I was curious. Like, I mean, in Tableau we don't need uh like include R or like
Correct.
Python.
So generally, when you do
That's
scatter
regression.
plot, right? Okay.
Yeah.
Generally, when you do scatter plot, this is one of the features we can add to scatter plot to show how the dots are moving. Are they moving in a straight line or not? Okay. So that's one more visualization technique that yeah. That's why Excel also has it. Okay.
Okay.
But I'm not sure about say SVM or decision tree. All the now in future it is if they build it, I won't be surprised. They might use Python concept in or R concept, okay, within itself, and they can build it. Okay,
Mm-hmm.
so it's not that it is difficult. These days we have many tools like Orange and other tools, okay, which what they do is they create UI kind of thing. Okay, here we're writing the code, isn't it? We are writing linear code. There you just drag and drop. Okay, you'll get the output. But behind one of this code is run, and people write Python or R behind because both are free language. See,
Mm-hmm.
if you use SPSS or SAS or any other tool, you'll have to pay royalty to the company. You have to buy the license.
Yeah.
But Python and R are totally free. Okay, so you can in the front end it could look like you're using Power BI in the front end. But when you do the drag and drop, behind they might be running Python query. They might be running R query.
Mm-hmm.
Okay, so it is possible. Okay, so see, every tool is trying to add its features and it wants to be the most preferred tool, right? So they can add so that you don't have to work with two different tools. And Tableau and Power BI are user friendly, isn't it? Drag and drop kind of thing.
Yeah.
Just select and drop it, right? So if they can add this, so it's no, I would say, not a surprise. They can do that. Okay, they can just allow you option, select the algorithm, and you get it. Okay, in fact, clustering is there in Power BI. I have seen. Okay, I've done clustering in Power BI. So you can do that, but behind what they might be doing is they might be running, okay, this query only in the data set.
Okay.
They might be running R. You don't have to run the R query. You just select which algorithm, you select the data set, you select XY, and say, okay, it will do, it will run the model directly. If you say X, these 5 columns are my X, this is what I want to predict, okay, and use SVM. Done.
Mm-hmm.
Backend, the code will be written, and you get the output in the front end.
Okay.
So I'm sure they will be using either Python or R because both are free.
Yeah.
You can also build an application in the backend. You can put R because you don't have to pay license for R, isn't it?
Yeah.
Okay. So yeah. So in fact, Tableau had actually lost its charm 5 years back. Okay, it was one of the most preferred tool 8 years back, 10 years back, but
Yeah.
5 years back it lost its place, and Power BI came up, and there are so many other tools, click tools, and I don't know,
Yeah.
few other things, ClickSense,
Yeah.
and
Yeah. Click. Yeah.
yeah, came up, and Tableau had actually gone down. The demand for Tableau gone down. Then Tableau added some of these data science kind of thing where it can
Yeah.
make predictions. You can actually do the time series analysis. Time series is also one of the algorithm that we do in machine learning, but you can do time series there. You add that 12 years, 12 months data, it will predict for next 3 months or 6 months.
Yeah.
So what it is adding the machine learning capabilities to your tool so that you don't even have to write complex code.
Mm-hmm.
Okay, so once you understand the meaning, what it means, what regression means, what SVM means, so when you see the output, you can easily analyze the output.
Mm-hmm.
Right?
Yeah.
So yes, so it's not a surprise that you can do machine learning also using these tools. It
Yeah.
will save your time. It becomes just drag and drop.
Yeah.
Yes. But at the heart, it is what you need to know, right? So
Yeah.
what happening, what those algorithm is.
Yeah, I mean, of course, you need to understand. I mean, if I've seen the graph without I mean, understanding the class, I wouldn't have understand what is this mx plus c or like square root square root value and all that.
Correct. Okay. Okay.
Yeah.
Okay. So now, so you can calculate all these things. We have something called as, okay, ML metrics. Now I'm moving to R. Let me share R now. Let me know when you can see my screen.
Yeah, I can see your screen now.
Yes. So here, um, so we can. I'll show you how to do manually once, and then I'll show you, how to do using inbuilt data sets. Okay.
So
So
this is all like part of overfitting or
no,
like
no, no, no. We have
underfitting.
not gone to overfitting.
This is just prediction, right?
Okay, we're looking at the metric.
Okay.
Okay, then I'll talk. When you understand the metric, then I'll tell you what underfitting, overfitting is.
Okay.
Okay, so just hold on. I just said I told you that those are the problems that can come. Okay, now I'll tell you. Okay, so let's say you want to calculate this mean absolute error. Okay, so your mean error. Okay, so let's say I call it as mean absolute mean squared error, right? That's the step that we have, right? Mean squared error, let's say, because RMSE that's the step, right? So to
Yeah.
to perform mean squared error, what we need to do is we need to minus this comparison marks minus comparison predict, right? Marks minus y predict. So I'm going to say comparison comparison, okay, dollar, okay, marks minus comparison dollar y predict. Okay, and so once you have this minus, then you have to do the average of these values, isn't it?
Mhm.
Okay, no, first square of this, then the
Yeah.
average.
Yeah. Square of this and
So you say you use this caret sign for to perform square. Okay, now let's see the print. Okay, so this is what happens. It did the square, right? Now I want to find the mean of it, right? So you simply say mean of the entire thing. Okay, the mean is 19.7348. This is what? This is your mean squared error. Okay, this formula is same as variance in statistics. Okay, if you want to find the RMSE, square root of this would give you RMSE, isn't it? So now we can calculate using inbuilt metrics. So we have something called as ML metrics. Okay. So let's say we go to package here and let's search for.
Can we, I mean, can we like look at the comparison data set once? Can you
Can
scroll?
we?
Look at the comparison data set once.
This is the one, right?
Yeah. Can you scroll up?
Yeah, yeah, yeah. Sorry.
No, I mean, I want
I know,
to,
got it, got it.
I
Okay.
want to like look at the records where the
Yeah, yeah.
value was same. So, oh, okay, okay, fine. No, no, I was just thinking that some of the values were exactly same, and why did we end up getting some values for like everything? But yeah, yeah. I mean, I see that there was there is some decimal point after all the
Right.
values. Yeah.
So, for example, if it is 32 minus 29.08, okay, and into 2.92, 8.52, right? So, this is what you got 8.5, isn't it?
Yeah, yeah.
Yeah. Okay. So, uh, packages ML metric is not also, let's install it. Okay. So ML metrics. Okay. So this is the, so let's install it. Okay. So this is done. So now I'm going to use it. So I'm going to say library. Okay. Now, so if you look at ML metrics, so this is not checked here, right? So when you see this name appearing, that means it is installed. If you see the name appearing on the right hand side, earlier it was not appearing. That
Yeah,
means
yeah.
it wasn't installed. It was not on a local machine.
Mm-hmm.
Now you see it is installed. That means it is on a local machine. It is already there, but it is not ready for use. We are not using it. So how do
Mm-hmm.
we use it? You have to say library of ML metrics. Okay. If I run this, this box will be checked there automatically. So if I run it, see this is checked. Checked means it is being used in the current file.
Okay.
Okay. So you have something called as uh, uh, if you want to find mean absolute percent error, okay, so we say mean absolute percent error, MAPE. MAPE is another MAPE dot value, something I'll give. This is the metric, and now I'm saying MAPE. This is the function, and it accepts the
Mm.
predict data and the actual data. Okay,
Okay.
so your this is our predict data. Okay, and this is our actual data. Right? Now you print make dot value.
The first one is just the square, and this is a square root. MAP is
No, no, no.
absolute.
Maybe it's percentage. Okay. So it is finding the this thing and then dividing by the actual value.
Yeah.
Okay. So it is dividing by the value. So see now if I tell you RMSE, one data has RMSE, okay, what we calculated. Okay.
Mm-hmm.
So let's say one data set has RMSE 100 and other has RMSE 10,000. Which is bad? Which one has the best RMSE?
The 100 one.
100 one, right? But if the base itself is, let's say, 2 digit, okay, so we're talking about marks and your error is 100, and there you're talking about 10 digit and you got 4 digit at RMSE.
Mm-hmm.
So that can now the 4 digit looks better, right? Here you're talking
Yeah.
about 2 digit marks and your error is 100. It is
Mm-hmm.
it means that very bad error, right?
Yeah.
There, if you're talking about 10,000 and if your error is 1,000 or 100, it is better. So your RMSE depends upon the input data also. Okay.
Okay.
But here what it does is it actually gives you a percent error. Okay. Based on the percentage of that. So it is divided by the denominator of the value. Okay. So now when I give you 2 MAP, you don't have to ask me what is the original data. But RMSE to answer, you have to look at the original data. You understood what I'm saying,
Yeah. Yeah.
right? Because the denominator is also important. Okay. If you're talking about thousands of data and if your error is 100 or 20, no big deal. But if you're talking about data which is less than 100 and your error is 20 or 100, it's a big deal, right? I mean, okay.
Yeah.
But May will take care of that. Okay.
Okay.
So generally, in forecasting, okay, when we do the forecast error, we generally use May. Okay. So MAP is your it's a forecasting error. You can look at the forecasting error.
Mm-hmm.
Okay. So now coming back to uh, underfitting and overfitting. Now see here. If I so here I use predict.
So
Uh,
the value that's showing up here like 0.0702, is it good value or a bad value?
okay. So these things we always compare and then we say which is good or bad.
Okay.
So this model gave you 0.07. Now, if some
Mm-hmm.
other model gives you zero point 0.9, 0.05, okay, zero point 0.9 or let's say 0.09, then this is better,
Yeah.
right? But if that gives you lesser than this, then that is better. So here, okay, we are always, I told you, right, two things that we ask after running the model. Okay, is this the best value that this model can give?
Mm-hmm.
Is this the best value that this model can give? That means we're talking about improving this model itself. Can we
Mm-hmm.
improve it to get better result? Second
Okay.
thing is, does any other model exist which is better than this? Or is this the best model?
Mm-hmm.
Right? So for doing that, you need to know MAP and this metric. Well, then you can say that, oh, no, no, this model is best. And with this value, this is the best value you can get.
Mm-hmm.
Okay.
Okay.
Now, if you talk about what is okay, now here if I give new data equal to test set, okay, it became a test error, right? Okay. Now instead, okay, I'll copy this and now I will say here training set. So now we are taking training data and calculating same stuff.
Mm-hmm.
Okay. 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 So we are calculating comparison predict, right? We bind yes. No, 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 no. So what happened was this data would have got your binding. So let me print this comparison. Is it working correctly? So you have 30 rows here, right? And here, how many rows you have before? 30, 30. And if I do test, then how many you have? I just want to make sure that we are doing correct this thing. 30. So did we say 50%? No,
80/20.
80/20, right? So your test and training should have different values. Or let's run this first. Data set. Okay, how big is so actually we'll have to run everything. That's a so if you have data set here, okay. Okay, so data set itself is 30. So everything is taking set 30, is it? Data set split equal to true training set. Now let's run this, okay? Run all of these one by one. How is giving 30 data set equal to let's go and print it here. Let's print training set, print test set. Okay. Now if I read this data, 50 split 30. Okay, both are getting exact same result.
Yeah.
Oops. Yeah, see here, we say split equal to true, split equal to false. Why is it not working? Data set marks. Sample dot split. Let me Okay, so we are using different strategy. Okay, instead of doing subset should also work, but instead we are doing data set. We are saying use only the split um, rows, and this is not split rows. Not split rows means false. Okay, so when you say 75%, training set will get 75% of the data here, and test will get only 25% of the data.
Yeah.
Okay, now you keep on executing. Okay, so training set, test set, okay, regressor. We discussed all this. Okay. we are finding. Okay, so this is for test set. Okay, so now this map that you see is test map. Now you do same thing for training. Okay, now you tell me training will have better accuracy or test will have better accuracy?
Training will have better accuracy.
Training will have better accuracy because you have trained the data on the data and then same data you're asking questions,
Yeah.
right? So it's like I gave you an assignment and the same assignment I'm asking you the questions,
Mm-hmm.
right? So obviously you will score better here than if I ask you different questions in the exam.
Yeah.
Okay, but it should be in the similar range. It should not be too off. That's what it says. So if you know, so MAP is or MAP is 0.239. Okay, training. So what it says is, okay, let's say if I obtained. Now, see, if you do not have large data set, right, then it is very difficult to see all this will come when you have large data. Less data, anything is possible.
Mm-hmm.
Okay. So now let's say you have create this one. Okay. So you have X and Y. Okay. Here we're talking about data, data or time, whatever. Okay. And here you're talking about error. Let's say you're talking about error. Right? MAP, MSE, all these are error only, right? So we talk about error, let's say. Okay, what it says is if you have less data, let's see this. If you have less data, error will be high. And as you give more and more data, as you perform more and more, your error will go down.
Okay.
It will be close to zero, but not exactly zero, but definitely close to zero. This
Okay.
is your training error.
Mm-hmm.
Okay, this is a training error. Okay, so training error will keep on going down because you are, you're running. So here you have data, or you are doing more tuning, right?
Mm-hmm.
Or you are, you are doing a different algorithm. So when you keep on tuning the algorithm, there is a saying, okay, just like when the criminals in the police custody, when police gives the police third degree, right? They call it, correct. So criminals will accept their crime, isn't it? So
Mm-hmm.
what this is saying that, if you torture too much, okay, your data will will accept whatever you say. So
Mm-hmm.
do not torture data too much. Okay, when you keep torturing the data, your error will go down to almost zero. So this is your training error. So training, because training error is on the same data you are doing the testing. Sorry, training also. But now when you perform test data, okay, what happens is initially, okay, if you say generally, okay, your test error will be a little higher, isn't it?
Yeah.
It will be higher, it will go down, okay, and after a certain point, it starts going up. Is it clear?
Yeah.
The green thing is when you perform, you calculate the metric with the test data. Test data error will be high. But after a certain point, you're torturing so much, you are doing the tuning so much that it is getting biased towards. It's like if I give you too much to read, okay, if I give you too much data to read, content to read, then
Mm-hmm.
what happens? You will start reading my notes only. You will not have time to read other notes, right? So,
Yeah.
and if I'm asking you questions, you have read all my notes, you'll be able to answer everything, but I will not be able to know whether you are thinking and answering or you are mugging up and answering. Okay,
Yeah.
so don't tell this in the interview, but from your mind, keep it, just to understand this graph. This
Mm-hmm.
is area where you are mugging up all the answers, and you're giving the answer without even thinking. You're mugging up because same questions have asked you, right? So you
Mm-hmm.
mug up and you answer in the final exam. Okay. Now, if somebody gets 100 marks in the exam, okay, you are not sure that person has studied, thought, and got 100 marks, or by hearted your notes and got 100 marks,
Yeah.
right?
Mm-hmm.
So definitely, when I don't teach you properly, when I don't give you enough data, you are like here. Your
Yeah.
accuracy will be very low. But when I keep teaching, hopefully your error will go down, down, down. But after a certain point, if I still keep teaching you, giving you more data, you are becoming dumb. This is what happens.
Mm-hmm.
Okay. See, job of any class, any teacher is to make you think so that you will be able to solve all your questions on yourself. But if teacher spends too much of time and talking about same concept and giving you more and more problems, okay, at one point what happens is you have so much that you'll stop thinking, you'll start mugging up.
Mm-hmm.
Because I'll be giving you all possible combinations like addition. If I'm teaching you addition, okay, I'll keep giving you all the possible combination 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, all combination I've given you. If I've given you all combination in the exam, okay, one of those combinations will come, you can easily say. So our aim should not be here to give as much data, to train as much as possible. No, train so much that the machine is able to think and answer.
Mm-hmm.
Our thinking algorithm is helpful to us, not the one which has bugged up and just giving whatever it has read,
Mm-hmm.
right? So that algorithm is not going to help us. So what you do is after a certain point, okay, that's why whenever you doing the evaluation, calculating those metric, you have to calculate both training set and test set, and see till some point, okay, it's going over, okay, getting difference is increasing, because you are so much of tuning and making it perfectly for the training data. Test data, it is going to fail very badly.
Mm-hmm.
Okay, so so the moment you realize that both are decreasing, okay, both in the sense your training data error and test data error, if both are increasing, okay, keep performing because you are in the underfit. So this is called underfitting area, okay, where the accuracy of both are bad, training and test are bad.
Mm-hmm.
As you go down, the improvement will happen. You can see the improvement. Let's say it's 2 o'clock. At 2 o'clock, you are um, what do I say? You are very energetic and everything. But what happens after this? Okay, you get tired and your error increases in the test. But training, since you have mugged up, you don't get tired because you're not
Mm-hmm.
putting in effort, right? So you don't get tired. So the error will keep on. So always when you compare, this is your overfitting area. Overfitting, okay, is when your training error is almost zero, very very low, and test error is very very high. We always look at the difference between training and test. If
Okay.
difference is less, that means you could be anywhere from here, anywhere. Okay, but if difference is more, that means you are in this area. But now, anywhere to anywhere, you should be here, where both are lowest possible value.
Mm-hmm.
Both the errors are lowest. It's not. So whenever you talk about futuristic prediction, how can your error be zero? You can't have zero error. What you can have is, okay, you can have is least possible error, and that least possible error is the perfect area. That's what we want to achieve. When we run algorithm multiple times, that's what we want to achieve.
Mhm.
Did you understand the difference between overfitting and underfitting?
Yeah.
Overfitting is when you're doing too much of anything. Okay, too much of data, too much of modeling, too much of analyzing. Okay, so you are doing. See, your algorithm should do, not you.
Mhm.
Underfitting is that you are being lazy. Okay, you are not. You should do little bit. To create a model to run it. So you are not doing that. Okay, so this is where you should be, and this is how we calculate. Okay, when I say when to stop, this is when to stop when you reach this point.
Okay.
So you won't be able to reach this point running model once. You have to run the model multiple times.
Mhm.
Okay? That's why you call it as researcher if you're doing this, right? Because you keep modifying, keep doing it again and again and again. You got the answer, you deployed it, but still you're working on the model because maybe some new thing might come up, a new idea might come up, and you can create a better model than what you already have.
Okay.
Is that all right?
Yeah.
So do not train too much, do not provide too much of data. Okay, just write and keep measuring training and test set. Okay, this is also called as bias and variance. This is variance. Variance basically means error,
Mhm.
and this is bias. Bias means you are being biased towards one side. So variance is that your model is high variance. Okay, high variance. The high variance means your model is not able to predict well. You are here, right? You are
Mhm.
here, so your error is very high. You are not able to predict basically. When you come down, your variance will be less. Less variance means probably you are able to make some progress. You are able to predict well. Bias means the difference between training set and test set is too huge. Understand? This is the training set. Sorry,
Underfitting and overfitting.
interfitting. Yes. So how do you know which stage you are in? No, you cannot know until you calculate both the value. Underfitting, overfitting values you calculate, and then you say, oh, I'm at level 3 or something. Okay.
Okay.
Now, okay, for multiple, okay, so we'll stop here. Okay. Tomorrow we'll talk about multiple linear regression. Now, running
So
is
tomorrow
easy.
can we not have a class because I have like interview around the same time
Oh,
tomorrow.
okay, okay, okay. All the best.
Oh, thank you.
I'll just pause it.